Cool. It is recording, so let's get underway. Cool. So, some revision from last week. Cool. So, what is the purpose of armoring in a cable, and when would an armored cable be necessary? Yep. Mechanical stress. Yep. Physical impacts or damage. All good, Blake. Cool. So, yeah, armoring in a cable provides mechanical protection to the conductors, making cable resistant to physical damage, such as crushing impacts or external forces. Armored cables are typically used in outdoor environments, underground installations, industrial settings, or hazardous areas where cables are exposed to potential damage. So basically, when it needs to be protected against being knocked about, or it's in a hazardous, like explosive environment. Cool. Describe the difference between single core and multi core cable construction. Yeah, that's the basics of it. Yeah, single core and multi core. Single core cable consists of one conductor enclosed by insulation. Multi core cable contains two or more conductors, each individually insulated and encased in a protective sheath. What are the traditional phase colours used in New Zealand for a three-phase cable? And as a bonus, what is the outdated colours for three-phase? Yeah, so we use red, white, blue now, and it used to be red, yellow, blue. So you'll find in a lot of older installations, you'll still come across yellow cable. As long as you're not messing with it, it is perfectly fine to leave it as is. Now, neutral conductors are black and earth conductors are green or green yellow. Why is it important to correctly identify neutral and earth conductors? What reasons can you guys think of why it is important to correctly identify neutral and earth conductors? Cool. So the neutral conductor provides a return path for the current to complete the circuit, while the earth conductor is a safety measure that carries fault current away to ground. Incorrectly identifying or connecting these conductors can lead to electric shocks, short circuits, and equipment damage. So yeah, Brian said the neutral is designed to carry current all the time because it's the return path, while the earth is a safety measure so that in the event of a fault, it'll carry current to ground, creating a low resistance path, which will trip the circuit breaker or fuse or whatever predictive device you're using. What type of cable would you recommend for use in a high temperature environment and why? Is more for your mechanical protection. It doesn't have very good heat dissipation. Fire rated rubber MIMS. Yeah, if you think about the way an armored cable works, you've got a metal sheath wrapped around the conductor. So that outer metal sheath, which is normally steel, which is why it's normally referred to as SWA, steel wire armor, would basically act like an oven and cook the cable on the inside. Cool. Yeah, well, you guys have said it. So yeah, silicone rubber, heat-resistant XPLE, or MIMS, mineral insulated metal sheath. Cool. What section of ASNZS 3000 is primarily used for determining cable installation requirements? Section 3. So section 3, we're going to be going over that a little bit tonight as part of what we're doing. Yeah, 3.8.3.3 is in section 3, but section 3 is all about the installation of conductors. Cool. So tonight we're going to be looking at cable installation and handling techniques as part of unit standard 32613. Cool. So we're going to do, how many of us are there? Okay, yeah. So we're going to do some group discussion. So you guys are going to have as much input as you possibly can. Just fire away. Kind of try to bounce off each other. I know it's in the chat. I would use the rooms feature, but it doesn't look like it's going to work with the recording. So group discussion. So have you installed cables on different services like concrete or? Cool. So we're going to go to the installation scenarios. Cool. Cool. So you've got some outdoor garden lighting to install. Cool. So the environment is residential backyard with soil, pathways, and garden beds. The requirements: install a weather-resistant underground cable to power garden. Lights, challenges: soil moisture protection against mechanical damage, compliance with burial depth. So what would you guys say is a recommended solution for this? So we give it a job to just put on some outdoor garden lighting in a residential backyard with soil, some pathways, and garden beds. That might be a bit overkill. Yeah, some conduit. Use solar lighting. Yeah, it's my preference. It's where most people are going these days with the garden lighting. Glued, yeah. Some guys will glue and duct tape. You want to think of anything else? IP rated fittings. Yep, that's definitely something. Hazard tape. Definitely going to need to use hazard tape if you're putting conduit 600 mil deep. Yep, orange is usually the stuff you use for underground. Yes, 24 volt. Yes, glad someone said it. Use extra safety, extra low voltage. Yeah. Cool. So recommended solution: use a direct burial rated cable, or run the cable through PVC conduit. Ensure proper burial depth, 500 mil, and use a weatherproof junction boxes and fittings. Yeah, proper burial depth should be 600 in my view. Yeah, you can go 500 if it's direct burial. 600 for buried conduit. Cool. Here's another one. Cool. So you've got overhead installation in a warehouse. The environment: it's a large industrial warehouse with steel beams and high ceilings. Requirement: install power cables to overhead lighting. Challenges: securing cables across a wide span, high vibration from machinery, and meeting safety regulations. Yep, cable tray. Cable tray is an option. A bit costly. Is there any other options? Beam clips, beam clamp, conduit to beams. Yep. Yeah, there's one more that no one said yet. Cat wires, there we go. Yeah. Catenary, yeah. So that's the proper spelling, what Blake's put there. Cat, E-N-A-R-Y. Cool. So recommended solution: use cable trays or catenary systems to span distances, ensuring proper mechanical protection and support. Regular intervals for securing cables to prevent sagging. Ensure compliance with safety clearance regulations. Yeah, you're going to need a EWP to reach the roof. Yeah. Yeah, so one thing to remember, guys, when you're pulling cables across cable tray and cat wires, you've got to make sure that you provide the appropriate amount of cable ties for the type of cable. So for TPS, you need to put in a bit more than if you're doing, say, steel wire armor or some of the circular multi-core cables, because they're self-supporting a bit more than TPS. So you always tend to cable tie TPS cables probably about half the distance you would for your bigger round cables. And please, please cut the cable ties. I was told there was. I haven't found it yet. But with cable tying on cable tray, I normally go every 2 or 3 kind of rungs of the cable tray. And then for a cat wire, I tend to use my hammer or something as a measuring stick. I think someone tried to tell me it was about 300 or 400 mil between cable ties. Yeah, I couldn't find a specific rig while I was looking this up for this, but I will keep looking tomorrow probably. Cool. Another one: residential plasterboard installation. Interior of a new residential build. Requirement: install power and data cables for lighting and outlets. Challenges: navigating timber framing, securing cables above ceilings and under floors, and avoiding mechanical damage. So what kind of solutions for running cable through a residential plasterboard installation? Yep, cable clips and stables. Yep. Yep, conduits for some of it. Yep. Yes, you need also. Don't know if you guys would know, but back in the day, what they used to do in some residential buildings is they would run steel conduit throughout the entire, steel conduit throughout the entire house, even down the walls to the power points. So everything was threaded. Yep, correct depth through stud. Yep, follow rigs for holes and timber framing. Yep, so the rigs, it's more of a building act. Oh, yeah, that would have been fun, Cody. So, yeah, so you're only allowed to take out from, just trying to remember the building act off the top of my head. You're only allowed to take out 30% of the stud, and you have to leave equal distance either side. So the 2x4, the max hole I would recommend drilling is a 25, because that's about 30 to 33% of the stud. But if you are framing in 2x6, so basically a third, 30%, 33%, a third of the stud. 25 mil is about that, or a 22. But if you're going up to 2x6, you can use 32 spade bit. 3604 2011. Cool. Good to know. Been a while since I've done my regs class. So cool. So use cable clips, pins, clips to suspend cables on timber frames, maintaining adequate cable support at regular intervals. Cool. Rural property power supply. So cool. Environment. Rural property where power needs to be supplied from a main building to a detached garage located 50 meters away. The ground is composed of hard rock and cannot be dug or into or chased. Requirements: install a power supply cable to the garage without obstructing the property's open space. Challenges: large distance between buildings, inability to dig trenches, and potential exposure to weather elements. So what would you guys recommend as solutions for that? Yeah, I suppose you guys are saying overhead wires. Cool. So use aerial conductors mounted on sturdy poles. Ensure the cables are weatherproof and tensioned appropriately, and comply with AS/NZS 3000 regulations regarding clearance heights over open spaces. Test the coil. Yeah. So with this, you guys would probably use hard drawn neutral screen. So it's a bit stiffer, and attach it either end to a pole with dead ends and bobbins. Probably quite a bit too far for cat wires. You may have to use multiple poles throughout, especially if it's 50 meters. Maybe pole every 20, maybe even 15 meters. You'd have to double check the span. Yes, you'd be surprised. But that is if you needed it to be off the main building, that's how you would do it. Probably definitely a solar at the same time for a garage. Yeah, solar. Cool. Sweet. So AS/NZS 3000 compliance requirements. Cool. So compliance with AS/NZS 3000 ensures safety, durability, and regulatory approval of cable installations. Section 3.3.2 of AS/NZS 3000 cites various considerations that need to be made when selecting cables for particular situations, such as ambient temperature, external heat sources, presence of water or high humidity, presence of solid foreign bodies, presence of corrosive or polluting substances, impacts, vibration, other mechanical stresses, presence of flora, fauna, solar radiation, hazardous areas, and proximity to other services. Cool. Let's quickly get that down. Hey, Ethan. This session's being recorded, so you guys should have access to it for at least a few days after the session. So yeah, you'll be able to watch it back. So yeah, try to take down as many notes as you can, and then we'll go over it. Yeah, all good, Zane. Yeah, so just take down as many notes as you can, and then you'll be able to watch the recording back, and then take down any notes that you missed. So yeah, we're just talking about AS/NZS 3000 section 3.3.2 and all of the factors that it covers. They'll be available in Teams, and if they're not, what I'm going to do is start uploading them to a private YouTube channel, and I'll be able to share the link for the videos with you guys. Normally, I would just send you guys the PowerPoints, but unfortunately, now that I am officially working for ETCO and Skills, they are now technically, because I've made them while I'm working here, the intellectual property of Skills and ETCO, and they got all a bit bent out of shape when I suggested that I could share them with you. To be honest, I did not know how. Be straight up honest with you. I did not know how to record. So yeah, I'm sorry about that. One of the other tutors showed me how to do it. Not very familiar with Microsoft Teams. Yeah, and I use it a lot for this is my day job now, so I have to start using it a lot. Yes, video will have the slideshow, but we're still gonna talk about it in the chat as much as we can. So try and take some bullet point notes down, but yeah, so we're gonna go over some of the stuff in 3000. I know what you're saying is we could just brush through all of this and you guys watch the video. Probably, but then I would overload you guys with knowledge and then the video wouldn't make sense. Cool. So moving on, anyone want a little bit more time? It's just bullet points to get those down. And I did a quick Google search. Yes, 3604/2011 is all about timber frame buildings. It is not one of the standards that's available to us through the standards portal for EWRB as part of our fees that we pay them. So you'd have to get a copy somewhere else, and it does cost. I think it's sponsored, so you may be able to. Yeah, you can download it for free for a single user document. Yeah, something to have a look at, but not something that I expect you guys to go and read on your own read on your own unless you want to. Cool. Cool. So this is 3.3.2.1 ambient temperature. So the only thing you guys need to know for this, that for cables in air, irrespective of the method of installation, so if they're exposed to air, the ambient temperature is 30 degrees Celsius. So it's above ground. For cables buried direct in the ground or installed in underground enclosures, the ambient temperature is considered 15 degrees. This is kind of ballpark, but these standards are now, 17 years old now. So a little bit out of date. So I would be looking at increasing the ambient temperature when I'm doing my calculations personally, just because the ambient temperature in New Zealand, because of climate change, is probably a fair bit hotter, and in ground probably as well. So I'd be personally, not saying you guys do this, 35 degrees for air and then 20 degrees for in the ground, just because climate change has increased it. Yeah, this will be in the slide, video afterwards, but yeah, just quickly write down now before you have to go back through the video again. Ambient temperature for air when doing calculations, 30 degrees. Ambient temperature for in-ground, 15 degrees. That is the accepted number for you guys to use. But again, it's up to you to go above the minimum standard when you are a tradesman. And who knows, by the time you guys get qualified, ASNZS 2018 may be current, or even they're talking about ASNZS 2025, 3000 2025. So moving on. Cool. So this is table 3.1. So this gives you basically installation methods. So unenclosed in an enclosure, and it just shows for the typical cables you would use. So for example, unenclosed, fully surrounded by thermal insulation, you'd be looking at insulated and sheathed, screened or armored MIMS and earthing conductors. And an enclosed on a surface, including cable trunk, you'd be looking at insulated, unsheathed, insulated, and sheathed, screened or armored MIMS and earthing conductor. This is just giving you guys examples of what it means when it says unenclosed in an enclosure on a surface fully surrounded by thermal insulation. There you go, on a surface partly surrounded by thermal insulation, supported by continuing wire, and then supported by insulators. So I was going to say the guys from the Haywards know what I mean, but the ceramic insulators that you see on the poles and at the switch stations. Cool. So you got presence of water or high humidity. So yeah, this is one you'll come across when you're talking about like bathrooms and wash stations. Wiring systems shall be selected and installed so that high humidity or the entry of water does not cause damage. Where water may collect or condensation may form in a wiring system to the extent that it creates a hazard, provision shall be made for its harmless escape through suitably located drainage points. Where a wiring system may be subjected to wave action, water protection against excessive flexing and mechanical damage shall be provided in accordance with clauses listed here. So that last section is kind of like where you're talking about wave action, you'd be talking about marinas. Don't know if you guys have seen any of the big boat ports. I don't spend a lot of time there, but they've got the connection points for boats to plug in. Obviously, there's no overhead cables, so all of the cables run underneath the docks or in the ground. But if it's a pier, there's cables that run underneath, and they're all pretty heavy duty. Fairly certain they're steel wire armored at the very least. And that drainage point is always a good one. So a lot of times, some guys will drill a small hole in outdoor fittings to allow the water to drain out. But realistically, they're probably supposed to be fully sealed. Yeah, a lot of guys tend to use that as an excuse for not using conduit glue in some areas. But water needs to drain somehow. But best practice is always glue and silicone. Cool. 3.3.2.5, presence of corrosive or polluting substances. So with the presence of corrosive or polluting substances, it's likely to give rise to corrosion, deterioration. Parts of the wiring system likely to be affected shall be suitably protected or manufactured from materials resistant to such substances. So that's when you're talking about your anti-corrosive or corrosive resistant fittings. Dissimilar metals liable to initiate galvanic action shall not be placed in contact with each other. So that's talking about dissimilar metals. So if you put a stainless steel screw through a galvanized steel beam, or just normal steel beam, or you put a steel screw through an aluminium fixture, they're dissimilar metals, so they may have a galvanic action, which means literal parts of one material will start to corrode and start to wick into the other material, creating holes. The best example is if you've got an earth stake in the ground next to a copper water pipe, over time as the soil gets wet, especially if currents passing through the earth stake to ground, that galvanic action will eat away at the earth stake faster and cause it to build up on the copper pipe or leach out into the soil. Don't know why I said cereal there. Sorry. Materials liable to cause mutual or individual deterioration or hazardous degradation shall not be placed in contact with each other. So you always want a kind of like a rubber spacer between materials if they're dissimilar, or if they'll cause mutual or individual deterioration. So effective substances such as esters, ketones, and ethers, aromatic and chlorinated hydrocarbons should be considered when using insulating conduit, enclosures, cables, or equipment. So things like vapors from paint fumes, if you're doing a paint booth, or chemicals that may off gas, like heavy-duty industrial methanols and things like that. Also, like before, we were talking about impact, 3.3.2.6. The wiring system shall be selected and installed so as to minimize the risk of mechanical damage. Protection against mechanical damage shall be provided by one or any combination of the following. So mechanical characteristics of the wiring system. So that's your steel wire armor cable or your running in conduit. Location selected, so you try and run it in an area that is less likely to have impact, and provision of additional local or general mechanical protection. So you may install your conduit running behind bollards or behind other objects that will cause it to be less likely to have an impact. And then you've also got 3.3.2.7, which is vibration. Wiring system subject to vibration that is likely to cause damage to the wiring system, including all cables, fixing, and connections, shall be suitable for the condition. So a machine is going to vibrate a lot. You don't want to connect it with, say, rigid conduit. You either use a flexible conduit or a flexible cable connection as to ensure no damage to the cable or connection. So if a machine vibrates with solid conduit attached to it, more than likely that conduit's going to break. Cool. So before we get any further, does anyone have any questions about any of that? I know it's a lot to take in. Again, you don't need to know all of these regulations off by heart. You just need to know that there is a regulation or a provision for this. So like if you're ever installing a cable and you're not 100% sure how to go about it, you can look at this section of the regs to, AS/NZS 3000 anyway, to help you in terms of what do I need to look out for. Cool. So presence of flora. So not everyone's aware, flora just means your basically your plant material. So is it going to be near plants that are going to overgrow and try to deteriorate it? Don't install TPS into a rose bush is probably a bit obvious, but yeah. So yeah, where the presence of flora is expected to constitute a hazard, either the wiring system shall be selected accordingly or special protective measures shall be adopted. I kid you not, I once saw catenary wires for some kind of fair, and they had TPS running along cat wires between trees. And then there was bad weather, and then all of a sudden the trees moved, and then the cat wires snapped and TPS fell to the ground. Very bad. Your presence of fauna. So where the presence of fauna is expected to constitute a hazard, either the wiring system shall be selected accordingly or special protective measures shall be adopted. So if you're running cables or anything through a pet store, you end up working in a zoo or a wildlife sanctuary, or there are going to be animals in the house like dogs and cats. The dog digs in the backyard. You just got to make sure that you take appropriate steps to make sure that your cables or fittings aren't going to get damaged by those fauna. So flora, plants, fauna, wildlife. And then you've got solar radiation. So where a wiring system is or may be exposed to direct sunlight, either a wiring system suitable for the conditions shall be selected and installed, or adequate shielding shall be provided in accordance with clause 3.3.2.2. Cool. What do we need to look for on conduit when we're installing it outside and not in the ground? What do we? Yeah. Cool. Yeah, there was a time. Yeah, UV rated. There was a time where you could buy. I don't know if you can anymore. There was two types of white conduit. You could buy UV rated and non-UV rated. I don't know why we didn't just make them all UV rated. So yeah, your non-UV rated would be used for kind of like inside commercial buildings, and your UV rated would be used for outside. It's not too uncommon to come across, especially in kind of older houses and people who have done DIY, people who have literally just pin clipped TPS to the side of the house and run it out along a piece of timber to the garage, or even a cat wire to the garage, and people who have pin clipped TPS to the side of timber in a outdoor patio, the what do you call it, pergola, over the top of a deck. Someone correct me if it's not a pergola. And they run that for their outside lighting or a sensor and a floodlight. I actually looked at a job on the weekend to fix some guy's lights outside his house and power going to his garage. Cool. Is there anything else that you think is important when other environmental factors to consider when choosing cables? Yes, it is usually flex or overhead cable. There is UV rated cable. You won't find UV rated TPS. It's usually circular cables like your XPLEs and your hard drawn neutral screens. But obviously, you guys are out there in the field. What's some factors that pertain to your job that most people wouldn't think about? Like, I know you guys at the Hayward substation, obviously you've got other factors like electromagnetic interference and Oh, that's one of the cable burn. Yep. Cable burn is something to watch out for. Yep. Yeah. One thing the guys wanted me to ask the guys working at the substations, do you guys still use mercury switches? Yes, that's a good one. Fat and oil. If you're working in a kitchen, no mercury switches. Yeah. Explosive areas. Yeah. There is a whole other standard for that. Okay. Flour getting into contacts and connections. Yep. So that is a big thing. Yeah, I've seen that a couple times too. Oh yeah, gone after the trolley bus was decommissioned. Hydrogen hazard area. Yeah. Especially if we start doing hydrogen generation for hydrogen cars, that's going to be a huge one that we're going to have to worry about in the future. One of the tutors here, his name's Alistair. Apparently, his dad used to go and do mercury poison tests on the guys at the Hayward substation because they would have massive open air vats of mercury that the switches would dip into. And he was telling me about it, and I'm like, that sounds like such a bad idea. But back in the day, they did a lot of strange things. Yep. So if dust and flour particles get into your contacts, it may seem like not such a bad thing in small doses, but if that then gets wet and bridges across your phase and neutral or across phases, it can create a pretty big dead short. Cool. So let's talk about current carrying capacity. Cool. So this is under 3.4.1. Every conductor shall have a current carrying capacity in accordance with the AS/NZS 3008.1 series, not less than the current to be carried by the conductor. In determining the required current carrying capacity, provision shall be made for reasonably foreseeable changes to external influences, such as the installation of thermal insulation in ceiling spaces and walls. In New Zealand only, wiring systems and domestic installations shall be installed on the assumption that thermal insulation in ceilings, walls, and underfloors, if not currently installed, will be installed in the future. So get that down because that's quite an important thing. So in New Zealand, we have to assume, even if there isn't already, that the cable that we're installing in a domestic installation is going to be, to me, it sounds like covered in thermal insulation, if not touching thermal insulation. So always assume, even if you're doing it, running it through a new build, that there's going to be insulation on top, around, especially the way builders are installing insulation now, is they put the bed up, mark where the cable is, put a slit up or down the insulation to match where your cable runs, slip the insulation in, and then bury your cable in inside the insulation. So at that point, your cable is then fully enclosed, which is why I don't use 1 mil in residential, because my current carrying capacity instantly drops because it's in it's fully enclosed in thing. No, spray foam is still quite expensive in New Zealand. It's more common to use bat insulation, even though it's a pain in the ass. The cost of foam is just too much. And I would prefer if they didn't use foam, because then I'm never getting a wire down that wall ever again. I don't mind it on the underside of the ceilings, or one house I saw, they did a double exterior wall. They built one wall, spray foamed it, and then built another wall inside it. Yes, Blake, that is true. Or you have to use that non-migratory cable that we were talking about last week, the purple cable you use in fridge and freezers. That stuff can be run under the house, and they can put polystyrene up over top of that. Yeah, polystyrene will leach out the the plastic inside the TPS. Forever installation, yeah. Yeah, just be aware if there's a polystyrene insulation, you need to use non-migratory TPS, and it is usually a purple color. Cool. Anyone need more time? Oh, you shouldn't need more time to get that note down. Let's move on. Cool. Volt drop. So we'll talk about volt drop a lot later, and when you go to do your regs and things like that. I'm just looking through my notes. Yeah, and we'll look a bit more into the next lesson, but you will, volt drop is a big topic that you'll cover in year 3 when you do your regs exam, because volt drop is part of your something you need to know for your regs, because it is a question that does come up. Cool. So under normal service conditions, voltage at the terminals of any power consuming electrical equipment should not be less than the lower limit specified in the relevant electrical equipment standard. So yeah, the value, so yeah, cross-sectional area of every current carrying conductor shall be such that the volt drop between the point of supply and the low voltage electrical installation and any point in that electrical installation does not exceed 5% of the nominal voltage at the point of supply. So yeah, it cannot exceed 5%. So it cannot be 5% too high or 5% too low. And there's actually, we will go into, you do go into the national grid, it'll either be next year or year 2, about the regulations imposed on the national grid in terms of the voltage ranges that they're allowed to supply to the customers. And then we're not allowed to let the voltage drop 5% of the nominal voltage at the point of supply. So yeah, the volt drop between the point of supply and the last power point in the circuit can't exceed 5% drop. So basically, to counter that, you increase the cable size. You can use the calculation apps for that. For example, I need to do a 50-meter run out to a shed and conduit over Christmas, and to allow for volt drop and the current carrying capacity, I need to run 10 mil twin and earth, or probably 16 mil depending on the price. Yeah, so that's 10 mil phase neutral and a 4 mil earth, or a 16 mil phase neutral and a 6 mil earth. So yeah, you can use EasyCalc, or Nexans have a good app that let you look through the catalog and do your calculations based on temperature and what you're running it in, and that'll let you know the minimum size cable, and then you can upsize it to something that's more affordable. So 16 mil is normally more affordable than 10, just because 16 mil gets used more than 10. Yeah, 5% volt drop is the maximum you're allowed. Yeah, so someone can work that out. Cool. So installation methods and compliance. Cool. So there are a few regulations that match up with the different types of ways we can surface mount cable. So you've got surface mounting. So this is where you surface mount your conductors either straight to the surface or. Cool. Cheers for sticking around, Thomas. Check out the recording later and make sure you get the notes down. Cool. So yeah, surface mount. So wiring systems likely to be disturbed. Wiring systems installed in the following locations are deemed likely to be disturbed and shall be supported at suitable intervals to prevent the undue sagging of cables on the surface of a wall or on the underside of a ceiling or roof. And you've got protection against mechanical damages. So wiring systems installed in positions where they may be reasonably expected to be subjected to mechanical damage shall be adequately protected in accordance with 3.3.2.6 and the applicable requirements of So there's a lot of referring to other clauses in the wiring rules and the regulations. So you have to be able to kind of jump between the two, between all of them. But going to 3.9.4, so where protection of a wiring system is required in accordance with 3.9.4.2 and 3.9.4.3.2. Oh, it's a lot of numbers. The wiring system shall be provided with adequate mechanical protection to prevent damage, or provided with an earth metallic armoring, screen or covering, or enclosure, or protected by an RCD with a maximum rated operating residual current of 30 milliamps. Yeah, where we surface mount things and it's likely to get damaged, we need to protect it with mechanical protection, earth metallic armoring, or RCD protection. Cool. So when you're installing conduit or trunking, so some things, yeah, it's back to the mechanical damage. Installed in positions where they may be reasonably expected to be subject to mechanical damage, adequately protected in accordance with the other clauses, and the applicable requirements of clauses 3.9.4.2 and 0.4.4. Cool. So the following types of wiring enclosures may be used for the protection of the cables requiring further enclosures as specified by 3.10.1. The conduits to AS/NZS 2053, including steel conduits or other metal tubing or conduit, flexible metal conduit, rigid and flexible insulating conduit, and corrugated insulating conduit. Cable trunking systems so these are other unit standards that fairly soon you have access to, but they're all to do with cable trunking systems and conduit. AS/NZS 4296, with or without compound filling. So trunking with or without a filling inside of it. And other wiring enclosures providing mechanical protection at least equivalent to those listed in items A and B. Yeah, so there is a standard for conduits, steel and plastic, and there is a standard for cable trunking. Cool, and here's something else. Cool, so bending. The radius of every bend in a wiring system shall be such that conductors and cables will not suffer damage. Bends in rigid conduit shall be such that the internal diameter is not significantly reduced, and changes of direction in trunking, ducts, or similar applications shall permit the bending of cables laid therein so as to comply with the requirements of this clause. And then see 3.9.6 for cable bending requirements. I'll look at that in a second, but so basically when it talks about the internal diameter is not significantly reduced, if anyone's done any copper pipe bending, you'll notice that when you do bend copper pipe without a form inside the middle of it, it changes diameter slightly at the corner. And if you've ever tried to bend conduit without a bending spring in it, you'll notice that it pinches more than anything else, which is why we have to use a bending spring if we decide to bend conduit. And I know it's a bit of a lost art. Has anyone done any conduit bending? Just out of curiosity, does anyone do it on the regular, or have they done it? Yes? Oh, that's good. Okay, good. Yeah, because some of the guys I worked with in my last company could not bend conduit to save themselves. This is good. Heat it up and bend it. Yeah, that works if you still have a little bit pear-shaped though. Hey, you gave it a go. I'm glad to see that you guys are actually giving it a go. Yeah, just so all of you guys are aware, the way I do the attendance, and I do have access to do the attendance myself now, is basically as long as you've posted in the chat regularly, I can search through the chat at the end of the night and then check how many times you guys interacted over the night and use that to do attendance. And a heads up, I don't care myself. They're looking at changing the policy for the online, how online works, and that having your screen on may be becoming a requirement. It's not confirmed. It's just something they're talking about. You guys can leave your screens, your cameras off for now. I mean, I've got mine pointing at the whiteboard. You can't really see my face for the most of this. So it's cool how it's going at the moment. So yeah, 3.9.6. So where wiring systems change direction, the following requirements shall apply. Bends shall not cause damage or place undue stress on their sheathing. Yeah, so that's the other thing. Not everyone's computer has a camera. Like if you're using a desktop computer or you're using an older laptop, so not all of them come with webcams. And it's a bit unreasonable for them to ask you to go out and buy one. Cool. So yeah, bends shall not cause damage or place undue stress on their sheathing, insulation, or terminations. Cool. Yeah, the bending radius recommended by the cable manufacturer shall be observed. So most cable manufacturers have a bending radius. Where manufacturer's information is not available, the following minimum internal radii may be considered suitable. Unarmored sheath cables, 6 times the cable diameter. So basically measure the cable diameter, that's your bending radius. And armored sheath cables, 12 times the cable diameter. So obviously armored cable is a bit more rigid, so you need to give it a bit more of a radius. Supports in contact with cables under pressure from changes in direction shall not have sharp edges. Cool. So yeah, changes in direction. So a lot of times in high-rise, like kind of new build apartments, they'll do a DB inside the apartment, and they'll kind of really kink the mains to get it into the main switch. If you do this, if you bend it so hard the cable looks like it's kinked, you're creating a hotspot where the kink is, because it makes it harder for the, if you think about a garden hose, makes it harder for the electrons to get around the corner. So it adds resistance and it causes a hotspot. So it's more likely to heat up, and eventually kind of melt the copper inside. Yeah, always make sure when you're bending your cables, especially in switchboards, you don't full on just kind of bend them in half, kink them over to get them into the main switch, because that'll cause a high resistance hotspot. Cool. Catenary wires, cable supported by a catenary. So cables supported by means of a catenary shall be stranded cables, affording double insulation or the equivalent of double insulation. So no conduit wires, please. TPS at a minimum. Cables and catenary supports installed out of doors shall be suitable for exposure to direct sunlight. So outside rated cat wires for outside. Cables are considered to be adequately supported if supported by a catenary and thereby relieved from excessive mechanical stresses. The catenary shall provide uniform support and consist of material equally resistant to corrosion or deterioration and be effectively fixed at each end and be capable of withstanding mechanical stresses likely to occur and partial those because of wind or ice, and be mounted at a sufficient height above the ground to prevent danger to persons or livestock or damage to the cable being supported. There is, in the later sections, actual heights requirement, and in other standards for boats and marinas and caravan parks, there are other heights as well that you guys will cover when you do your regulations. So this is all good information to know, but you will go over some of the stuff again when you do your regs in year 3. Cool. So note, catenary may form part of a cable, in which case it should be installed in accordance with the manufacturer's instructions. So that's your like your hard draw neutral screen with a bobbin and dead end at each end. Clearances. Cable supported by catenary wire shall maintain the following clearances. An outdoor location is specified by 3.12.3 for a neutral screen cable, and in an indoor location, not less than 100 mil from any moving parts or parts of equipment operating at an elevated temperature. So yeah, you should have at least 100 mil clearance away from any moving parts or equipment operating at an elevated temperature. That includes hot water pipes running through the ceiling. Does happen in some commercial spaces. hot water pipes and aircon pipes running through the ceiling. They do change temperature, so we need to make sure we're at least 100 mil away from those to protect our cables from the heat. Cool. Conductors used as aerial conductors shall be hard-drawn bare conductors or polymeric insulated cables or neutral screen cables or parallel webbed, twisted, or bundled insulated cables. Yeah, hard-drawn bare conductors or hard-drawn neutral screen cables, and yeah, those are the ones you come across more. Cool. Oh, here you go. Cool. Table. So aerial conductors. Table 3.8 specifies the minimum aerial conductor clearances. Cool. So yeah, you got your type of aerial conductor. So you got bare live, insulated, and unsheathed, and you got your neutral screen. Neutral screen cables over areas used by vehicles. The minimum height above building structures, ground, or elevated areas, 4.6 meters. So about the height of a truck. Over areas not used by vehicles, 3 meters. So you can't jump up and grab it. Over roofs used for traffic or resort, 2.7 meters for neutral screen. And then things like over roofs and structures, horizontal clearance from walls, and all this and the other. So it's got your clearances and your heights. Yeah, so it's got your height. So yeah, above a building needs to be over 1 meter. From clotheslines need to be 2 meters above those. From telecommunication lines, 600. Above swimming pools, bare live conductors are not permitted above swimming pools. Can anyone guess why that is? Same with above where sailing craft or irrigation pipes are used. And tell me why that's most likely the case. Yes. Evaporation, yeah. Possibly. But yeah, mostly if it breaks, it'll fall in the water or on the water pipes and liven it. There have been cases, especially with high voltage wires. Yeah, yeah, that's the best way to put it, Jack. Water electricity means bad. Has anyone seen where they Mythbusters tested the peeing on the electric fence and how if the water is conductive enough, especially irrigation, whatever the salts they add into it, there's potential of the voltage jumping across these streams of water and getting shocked. But obviously, irrigation pipes and sailing craft, bare live conductors above sailing craft. If the mast touches that, although, yeah, if there's a sailing craft going anywhere near my cables, I'm just going to get worried, and I'm not running my cables over open water where sailing boats tend to travel. It's 4.5 meters. Anyone know off the top of their head how tall a sailboat mast can get? I think it's a bit more than 4.5 meters, isn't it? Cool. 6 meter? Yeah, well, depends on the size of the boat, right? I'm pretty sure some of them can get up to like 20 meters. 12-ish, yeah, cool. So yeah, so distance between your supports for your spans, 14? Geez. Okay, so the length of span of aerial conductors shall not exceed the value specified in table 3.9 for the appropriate type and size of conductor. Exception, spans greater than the value specified in table 3.9 may be used provided the design is in accordance with sound engineering practice. So basically, if an engineer tells you it's okay and he signs off on it, cool, it's his problem now. If the table says no more than 5 meters, but the engineer says nope, you can go to 8. Cool. Give me a piece of paper saying you said that. Yeah. Insulation of aerial conductors. So aerial conductors shall be insulated in the following situations. Any conductor span that is attached to a building or structure. The exception is this requirement need not apply to aerial conductors between and supported by two independent poles or similar independent supports. If any conductor span within arm's reach of any building, building opening or structure. So basically, if I can stand on a deck and reach the cable, or I can stand or put my arm outside the window and grab the cable, needs to be insulated. Above areas where sailing craft or irrigation pipes are used, see table 3.8, but personally, no. In areas declared by the responsible fire authority as being subject to bushfires where required by the regulatory authority or the electricity distributor. So basically, if the fireman says it has to be insulated, it needs to be insulated, and if the regulating authority in the local area or the electrical distributor says it needs to be insulated, you kind of just have to go with it. And here we go, table 3.9. Cool. So for a bare hard drawn copper, less than, greater than or equal to 6 millimeters squared, the maximum span is 60 meters. Cool. Insulated hard drawn copper, including 2, 3, and 4 core twisted, but excluding neutral screen. So for 6 mil, 40 meters, for 10 mil, 50, and anything equal to or greater than 16 is 60. Here you go. So for neutral screen cables with hard drawn copper conductors, for 2 conductors, 6 or 10 mil, 40 meters, 3 conductors at 6 or 10 mil, 60, 4 conductors, 6 or 10, 50 meters, and then 2, 3, or 4 conductors, 16 or higher, I'm guessing, 60 meters. So this gives you, so you've got to get from that main building to the out to the shed we were talking about before. If your cable is, look, what was it, 50, if you've got insulated hard drawn copper, 2 or 3 or 4 core, and it's 10 mil or bigger, you can have a 50 meter span and it's all good. You have to make sure that your cable is able to do that. Otherwise, you'll have to put posts in between. Cool. Much more common, underground. Cool. Cables installed underground shall be suitable for the environment, provided with protection against inadvertent damage. So that's when you're talking about the mag slab and the danger tape. And provided with suitable warnings. Oh, that's suitable walkers marking. So provided with protection against inadvertent damage likely to be caused by manual or mechanical excavation work. So that's your ducting or rated like as buriable. And then you've got to have the warning markings, other means to rescue inadvertent damage. Personally, not a fan of direct bury cables, just because you have no idea when that depth of ground is going to change. Maybe they decide they're going to lower the backyard by 200 mil. All of a sudden, it's not buried deep enough. And the conduit just means that if you want to upsize the cable, you can change it later. Cool. And then we talk about the classification of wiring systems. So rigid caution tape, mag slab. There is a, I'll cover that when we get to the table. Cool. So classification. So you've got 3 types, A, B, and C. So A is inherently suitable for installation below ground and no further mechanical protection is required. B is one where the additional wiring system is suitable for installation below ground only with additional mechanical protection. And C, which wiring system is laid within a chase channel in the surface of a rock. So category B is where you talk about the rigid caution tape or the mag slab. And here you got the arrangements. Category A, system where cables are enclosed at heavy duty insulating conduit without further mechanical protection. System where cables are enclosed in insulating wire enclosures encased in concrete. System where sheath cables are enclosed in galvanized steel pipe. A system where armored sheath cables or neutral screen cables are buried direct in ground without mechanical protection. Your category B, following systems: system where cables are enclosed in medium duty insulating conduit with additional mechanical protection, where sheath cables are buried direct in ground with mechanical protection. Mechanical protection for a category B underground wiring system is detailed in later clauses. And then C, recognized by the standard is where cables are chased in rock and then covered with concrete. Here, you've got heavy duty conduit. So yeah, here's your type of cables down the right-hand side and your method of protection. It'll talk about for the mag slab, it'll talk about that in the later clauses. A lot of the times it's down to either regulation requirements or your engineer. Hold up. Let's have a look, shall we? I have a copy of ASNZS 3000 2007 open. What did it say? It was clauses 3.1.4.3. Yeah, so minimum depth of cover. Oh, come on. Cool. So here you've got your table 3.6, which is your minimum depth of cover. So within confines of a building and elsewhere external to the building. So there's no surface covering of less than 75 mil thickness. No surface covering or less than 75 of concrete. Your minimum depth for Cat A and B is 500 mil. That's to the top. The 500 mil to the top of the ducting. So most of the time you dig 600, you're allowing for 100 mil of conduit. And then you need danger tape 100 mil above that. And you must bury it in sand. Yeah, so wiring systems underground shall be identified by an orange marker tape complying with, in order to provide early detection of the presence of underground wiring during excavation work. Marker tape shall be positioned at approximately 50% of the depth of cover above the wiring system. So if the top of your wiring is at 500, your danger tape needs to be at 250. Where the wiring system is chased in rock, orange marker tape shall be laid directly on top of the wiring system where the concrete is poured. Underground wiring, don't worry about the exception. And then it's got examples here. So this is your 75 mil minimum continuous poured concrete, 150 mil to the marker tape, 300 mil to the top of the cable, and you've got 50 mil top and bottom of sand. Cannot be stone or rock. Here you've got ground level, no covering or less than 75 mil of continuous poured concrete, 250 to the marker tape, 500 to the top of the ducting or cable. Yeah. So the mag slab also counts as mechanical protection. So this is an example of a category B underground wiring system. It's a ground level, no covering or less than 75 mil of continuous concrete, 250 to the marker tape, 500 to the mag slab or mechanical protection, 75 mil to the top of the cable or ducting, 50 mil top and bottom of sand. So it depends, all depends on what category, and these are examples. So here you got your mechanical protection. So that's normally what mag slab is for. It's a mechanical protection, but also when you do your reader over the top, they go around with the cable reader. It's easier to find, especially through poured concrete like this, or just because of the depth of this. Because if you're going 575 mil to the top of the cable, that extra 75 mil could be the difference between them picking up the cable or not, which is why we need that mag slab or the mechanical protection. Here, so yeah, it's type C. So you got concrete chased cut into the rock. You've got the marker tape straight on top of the cable, and it's buried in concrete. There you go. To minimize damage, wiring system installed underground during manual and mechanical excavation shall be marked or recorded as follows. Permanent cable marker signs shall be provided to indicate the point where cable enters or leaves a structure. Cable entry signs need not be provided where the position of underground cable entry into the ground is obvious. So the route of any underground cable shall be recorded on a plan. Talks about spacing from other underground services. And here you've got your minimum separation at table 3.7. Aerial warning systems. This just talks about arrangements of aerial conductors, safety warnings. Yeah, so that mag slab doubles as mechanical protection, but also gives excellent early warning, especially if the cable is buried deeper. Here you go. So here's the depth. You've also got, and then here we go. We looked at this one before, talking about the marker tape and the burial depth. Cool. Cool. So just got one more thing to look at. Cool. Okay. Got about 10 slides left to go, guys. So looks like we'll be out of here hopefully by 7:15, 7:30. Cool. So drawing in. So cables get pulled into conduit, and you need to take care by use of usually a draw wire or being pushed along as the conduit is installed. I get these PowerPoints and then I usually have to edit them a bit. So sorry about the miswording there. So yeah, cables get pulled into conduit by use of usually a draw wire or being pushed along as the conduit is installed. If conduit is already installed, you can use, you guys know the baggie trick? You take a little baggie of plastic, tie it to a lightweight, tough string, put it into the conduit. The other end, you put a vacuum on it and just suck it all the way through. I think the longest run of conduit I've done that on was 250 meters of solid rigid conduit. And yeah, 300 meters of string goes pretty quickly when it's being sucked through the conduit with a vacuum cleaner. So yeah, if you guys are ever stuck trying to get conduit in, or people have put ducting down and they haven't left you a draw wire, exhaust fumes, how does that work? I need to know now. So what, you push the exhaust fumes through the conduit and that pushes the wire along, or it pushes the baggie? Or is it that the old radiator store trick? I need to know how this works now. Oh yeah. Yeah, that's a good way of doing it. But yeah, most guys, yeah, you've got a vacuum cleaner or like even a battery one will do it a pinch. Check around. Gases push it through, I assume. Yeah. Yeah, as it flows. Yeah, because the gas wants to escape, and it's yeah, it's trying to get out. Yeah, cool. You can then attach your wires to the draw wire by twisting and taping. So you strip the copper, twist it into a hook, tie the string on, tape the ever living shit out of it so it doesn't come off, and then pull slowly but firmly. Cool. So care needs to be taken when pulling, as excessive force can damage and burn insulation. If existing cables are in conduit, extra care must be taken not to burn the insulation of the existing cables. So that's why you pull just kind of steady and slowly. You don't kind of yank it if you can avoid it. Vac truck. Oh, yeah. Cool. So cable lube is your friend. Can be used to help pull cables through long sections of ducting conduit with numerous bends. Just makes life so much easier, and it doesn't cost that much for a litre bottle of it. To avoid cables twisting, pull cables straight off the drum into the conduit instead of pulling the cable off and then pulling it. Yeah, sometimes it's easier to pull out and measure, but if you can pull straight off the drum into the ducting or the conduit, it works a lot better for not getting it twisted because the cables will just kind of peel off nicely in a loom. There have been situations where I have not followed any of this advice. One time we had a stubborn mains cable pull, so we put a couple screws through the end of the cable. We had a heavy-duty rope attached to it, duct taped the crap out of it, covered it in lube, and then attached the other end of the rope to the company ute and drove. It was dirty, it was quick, but it got the job done. I've seen guys use an EWP where if the conduit's coming up out of the ground, they'll have the EWP, the string pushing forward. And once it's got tension, they'll lift up on the rope, which will pull the cable through. They'll move the EWP forward till it gets tension, lift, tension, lift, tension, lift. And then if you run out of room, back it up, tie it off again, and go again. Yeah, so cable burning is definitely a thing. So yeah, be careful with that, and just be careful because the lube is usually not safe to ingest. And I once had a fellow apprentice when I was doing my time ask if he could use it instead of normal lubricants. I don't think he got qualified. I just looked at him and then walked away. It is not safe for that application. Cool. Love it, Timothy. Good. Cool. Yeah, running placing. So yeah, cables are run along surfaces in residential with either cable clips or pin clips. So cable clips are the plastic ones that you hit in with a nail over top of the cables, and the pin clips are the ones that you hit in first, lay the cable over, wrap it around, clip it, tab it off. Cables should follow the most direct path and minimize bends. It's always good to minimize bends. Cables should be spaced out as much as possible to allow for heat dissipation where possible. Always try not to run too many cables with your hot water, your oven and your hob cables, just because they're going to have a lot of current running through them at one time continuously, especially if you're cooking dinner or the hot water is heating. So they'll get the hottest. So try and keep those separate if you can. In industrial and commercial settings, cable tray may be used to run large amounts of cables through a space. Cable ties should be spaced evenly to attach cables to cable tray based on the cable type. Like I was saying, TPS need more cable ties than your big round mains cables, just because they're more likely to twist, lift off, and act all annoyingly. Cool. Terminating. So stripping the cable insulation should be done carefully with the correct tools to avoid damaging the conductors. Use crimp connectors, lugs, or terminal blocks as appropriate for the application, and ensure that the termination is secure and free from loose strands, which could cause arcing or overheating. So yeah, stripping the cable, use your pliers, sidees, or your spring-loaded automatic strippers. Can use a knife for some of the more annoying cables, or your round cables. 1 mil flex will fit into those automatic strippers, the spring-loaded ones. But if you try and put a 1.5 3/4 flex in there, it does tend to break the spring, as I found out once. Cool. Crimp connectors, make sure you're using appropriate crimps to do the lugs and the crimp connectors up. Terminal blocks, make sure they're the correct size. Don't try to shove a 6 mil into a 4 mil hole. You can, but it's not a good idea. Ensure the termination is secure and free from loose strands. So make sure that no strands are sticking out of it. And make sure you do your loops in copper wire. If you're using copper wire, don't do what another idiot apprentice did, and he tried to jumper a connection in a temporary lighting terminal box with catenary wire. The only reason it didn't work and turn on is because he forgot to hook up the neutral. So glad he didn't hook up the neutral that day, because that temporary lighting box was sitting under the building for almost 3/4 of a year. Cool. Let's talk about some real world scenarios. Cool. Cool. So your cables are buried too shallow underground. Cool. So in the scenario, electrical cables are buried just below the surface in the garden without adequate depth or protective covering. Cool. So what's the potential damage? What's the potential shovel strike? Yep. Or something other than mechanical damage. What kind of damage could you get in a garden? Moisture, hungry dog, yeah, or cat. I find cats are just as annoying for that. Roots, yeah. Yeah. If it's laid on top of a rock and then you put a heavy pot on top of it, could pinch it. Yeah, cool. So the potential damage, shallow cables can be easily damaged by gardening tools, shovels, or other outdoor equipment, leading to exploded wires, electrical faults, or safety hazards. I agree the moisture is also an issue, especially if it's not rated for moisture, especially if it gets a little nick and moisture gets into the cable and starts to corrode the copper. Cool. So what can we do to prevent this? Yeah, dig deeper. Anything else? Yeah, correct depth and ducting, definitely. Conduit, yeah, conduit. Cool. So yeah, recommended prevention: follow proper guidelines for cable burial depth, typical 500 mil or more for low voltage cables, and use conduit for additional mechanical protection as well as moisture protection, glue, and I always like to glue and duct tape if I'm doing it underground. That way, it's definitely not coming apart. Cool. So unsupported or dangling cables in suspended ceilings. The scenario: cables are laid loosely above suspended ceiling, resting on the ceiling tiles, or dangling without proper support. What potential damage is there? Movement of structure could loosen them further. Yep. Yep. Weight on the ceiling could make it fall. A definite one. Yeah, those suspended ceilings aren't really held on by much most of the time. Cool. So ceiling tiles can become damaged or sag due to the weight of the cables, potentially causing them to fall. Yep. Dangling cables can suffer from strain, leading to insulation wear or damaged conductors over time. What can we do to prevent it? Cable sport, cable clip them. Use cat wire, yep. Yeah, so use cable trays even, hangers or clips to properly support cables above ceiling spaces, ensuring they're not resting directly on ceiling tiles or, cat wire and cable ties. Always cat wire and cable ties. Cool. Use of incorrect cable types for load requirements. Cool. Scenario: electrician installs incorrectly rated cables in a commercial kitchen to power high wattage appliances, underestimating the power draw. He also didn't realize it was going to be three-phase. What's the potential damage? Bye-bye kitchen, bang. Cables will overheat. Cable's going to burn out, machines won't work properly. Cool. So cables can overheat due to the excessive current, leading to insulation melting and increased risk of fire. And what can we do to prevent this? It's pretty straightforward. Use the proper cable. Always calculate load requirements accurately and select cables with sufficient capacity to handle the expected current. General rule of thumb, guys, we normally protect the cable, not the device. So we know that this machine requires a 32 amp breaker. We know, cool, minimum 6 mil. 32 amp, minimum 6 mil. And then if it's a long run or anything like that, move up to 10 mil. General rule of thumb, and this is not something that you should be, you should always do your calculations, but generally anything over half a drum or anything over 50 meters, upsize. As a general rule of thumb, if I'm running a 16 amp power circuit and it's over 50 meters, might be able to get away with it. But if it's 20 amp circuit over 50 meters, I want to be going up to 4, maybe 6 mil just because of the run. But always do the calculations if you need to. If it's a long run and there's a lot of insulation, do your calculations. Cool. Running cables across sharp edges without protection. Cool. Scenario: cables are run across sharp metal beams in a workshop without protection, and they occasionally shift due to vibration from nearby machinery. It's the potential damage. Wear through the insulation. Liven up the beams. The breaker could keep tripping if the metal is bonded like it should be. Definitely could liven up the metal beams. So the potential damage: constant friction and pressure could wear through the insulation, exposing live conductors, which could result in electric shocks or short circuits. Steel frame buildings should always be bonded. They should be connected to earth through Rio. So if a cable breaks, sometimes it may be too high resistance, the combined phase and earth circuit, but hopefully it'll break through the earth at the same time. I know it's not a good thing, but what can we do to prevent this? Use more zip ties. Yeah, suspend the cable from something. Kevlar tape. That's, yeah. Cool. So simple, just use grommets or protective sleeves where cables pass over sharp edges to prevent damage to the insulation. Just try not to run them over sharp edges. One thing we do in commercial, if we drill through the top plate of a stud, we'll either drill a 25 or a 32 mil hole, and then we'll use the corresponding flex conduit, shove it through the hole, and put a cable tie top and bottom, or put tape on one side so it doesn't fall down, and we'll run our cables through that. And if we're not using a pre-made rounded off hole through the studs as well, we'll do the same with the conduit to make sure it doesn't rub on the metal. So that's one way you can get around it, because the conduit's fairly rigid and it won't, the metal won't cut it unless you put a lot of force behind it. Cool. Over tighten cable ties on data cables. Cool. Scenario. A technician installs network cables in a commercial building using cable ties. To ensure the cables are secure, the ties are tightened too much, compressing the cable insulation. What's the potential damage for these network cables? Yeah. Yeah. Sever or break the cores. What if bundling those data cables, there was a fiber optic as well? Yeah. Glass. So you probably break, to be fair. There was fiber in there as well. Yeah. Cool. So excessive pressure can crush the insulation and internal conductors, leading to degraded signal transmission and potential intermittent faults. Over time, this could result in data loss or slower network speeds. Yeah, Troy's getting ahead of me. Yeah. So what's the way to prevent it? Yeah. Yeah, the worst part is with network cables, they run them individually, especially in commercial buildings. So you damage one, you have to replace the entire run. And if that's a 70, 80 meter run, that's a really, really long job, especially if it's a finished ceiling. Yeah, so what's way to prevent this kind of damage? Separated conduit. Don't over tighten them. Yeah. Data trays. Yeah. So we normally run, it's normally cable basket rather than tray. If you've been on commercial jobs, you'll be able to tell the difference. But yeah, cable basket is actually a little bit easier to work with than cable tray. It clips together nicely. Yeah, so use appropriate cable ties designed for data cables, so Velcro ties or ties with wider surfaces, and ensure they are loosely fastened to avoid compression. Data guys will pretty much exclusively use Velcro ties. They'll just have one big spool of Velcro, cut it to length, wrap it around the cables, and this makes it easier to add cables into the bunch later. You don't have to cut the cable tie. You can just undo the Velcro, put the cable in, redo the Velcro. Cool. So, yeah, that's all we have to cover for tonight. 1 second. Yeah. Cool. So, yeah, just make sure you guys do work on your online stuff. I can see you have or have not completed your modules. If you need something opened, you need to email Mark Actually, I will post this in the chat. Yeah, there's a specific format. He will have, I will send you a format. Yeah, he likes to do it, have you send it in a specific way, because that way it pops into a separate folder for him. Sorry. Yeah, that's the format. All good, Troy? Troy, what's up? Yeah, so if you need it reopened, email Mark using that format with the subject Hive. Yeah, he does go through it on Tuesdays and Thursdays. I can't open any of the attempts again. Yeah, it's okay. All right, but yeah, if you need it open, email him. If you guys need help with specific questions, then send me an email. I can look through the whatever assessment you're needing help with, and email you back with. I try not to give you the whole answer, but try and push you in at least the right direction, fairly obviously. So after the second attempt, it locks you out for a stand down period. I don't know why, it's just the way they designed the system. And then if the stand down period means it puts you over the close off date, it will let you know. But yeah, so it may have been cut off, but yeah, after your second attempt, I think it's a 24 or 48 hour stand down period. Yeah, if it's locked, then you need to email Mark. Today is Tuesday. He'll do the next unlock on Thursday. So if you guys email him tonight or tomorrow, then he should unlock them for you on Thursday. And then by Friday, you guys should be able to have another go. If you're not sure what the answer is to that question you got wrong, yes, you'll still get your third, if not fourth, and then fourth attempt. If you're struggling with anything and you're not sure what the right answer is, again, email me, let me know. But that's all for tonight. Unless you guys have any more questions, I will stop the recording, and then you guys are free to go. Yeah, yeah. So we've got 2 weeks left, guys. 2 weeks, so one more week of class, and then we've got the end of year test. I will have some revision for you guys next week as well, to go over exactly what's in the test. It will be basically anything we've done this term. It won't be anything from last term, just this term. I have had a look at the test, so I'll be able to tell you basically what's in it.